All right. So today what we're going to do is start to talk about classes and objects. And this is a topic in computer science called object-oriented programming. So up to this point, we've been organizing our code using conditionals and loops, and recently functions. We added that to our list of abilities and knowledge. We know now how to isolate code into functions and how to package some functionality inside of a function, invoke the function, and get the result, do something with it. So writing functions, putting code inside of functions is one way of managing a growing software system. It helps maintain order in that system. You actually don't need functions. You could do everything without functions, but it just becomes hard. It becomes hard to write code that's, well, the code that we're looking at is small, but in real life code, code is very large. Usually at least several thousand lines of code, if not millions of lines of code for very large scale systems. And so when you're dealing with that that level of complexity, you need to have these standards or forms that you use to help kind of keep all the logic organized and maintain it in a state where it can be read, where it can be maintained. If you need to do something, you need to modify the system. You need to find your way through to those parts of the system that need to be changed or extended. And object-oriented programming is a fairly recent development in computer science. I don't know exactly. Maybe it was 20 years ago or 30 years ago. But there was a time when there was debate about whether objects and using an object-oriented approach was useful, but there was a big transition in the industry towards object-oriented programming at some point, and pretty much most everybody now is thinking in terms of object-oriented design, although there are some exceptions. So anyway, let's talk about this. So we have this concept of an object. So it's an abstraction, a simplification. We've got, last time we looked at functions. We have a function. A function is something that you invoke, it does work, and it returns a result. All right, simple. So now we have something like an object. An object is, you can think of it as a thing. It's an entity. It has behavior. You can tell it to do things. And it has state. So, I'm happy today, or I'm unhappy today, I'm sad today. So I have state, right? I have my internal state that if you ask me about it, I'll report it to you. I'll tell you what I feel like today. And some things I'm not going to report. I'm going to keep some things hidden away, right? It's the same thing with objects in programming. You've got objects that have their public API, the public interface, and you can query those objects to find out information about that object state, and you can also invoke functions on an object to modify that state. And but some things are hidden away and that you can't access through its public interface. So we're going to look at examples of this just right now. Actually, so what we'll do is just go ahead and start working through Lab 6. So let's go ahead and read through exercise 1 and carry this one out. Carry out the solution for this. All right, so this exercise refers back to Lab 5, Exercise 2. So we're going to keep the same functionality that we implemented in Lab 5, Exercise 2. We're just going to do it in a different way. We're going to use objects instead of not using objects. Question back there.
Well, if you're talking about the random colors, that's Lab 5, Exercise 1.
Lab 5, Exercise 1. So I need exercise 1, right? I should be doing exercise 1. Okay. Let me change that. Thank you for correcting me on that. Lab 5, exercise 1. So what did we do last time? We did, the is prime, right? So this is actually what we don't want. Okay, I wasn't even thinking about that. Let's do lab 5, exercise 1. Okay. Do I have a copy of lab 5, exercise 1 anywhere? So, Michael, I think this is your lab 5, exercise 1. Can we use your code? What's that? Don't change the repository? Okay. All right, let's take a look here. I'm just going to clean it a little bit, make it my style, and I do line spacing a certain way. You can see there's tabs in here, and sometimes there's spaces. And in general, it's a little bit safer to omit tabs and to use spaces instead. Because if the code is going to be managed or viewed inside different tools, then that's in the case of a project where you have lots of people, or if you have like a public resource, it's better to use spaces instead of tabs, because different tools interpret the tabs differently. All right, so here is the code. I'm just going to clean it up a little bit. So we have a get color function, and then there's the purpose of this function is to generate a color string that is used inside of a web page. Here's the main function, and we seed the random number generator here by calling srand. If we don't do that, we'll get exactly the same random number sequence every time we run the program. So by passing in a different value each time to srand, we will usually get a different sequence of pseudo random numbers. Pseudo, those are not true random numbers. They're numbers that are generated through an algorithm that is predictable. And so what do? We declare a string called color, and then we start outputting the HTML, and then we enter into this loop and generate the 100 list items that have the color values in them. Let's see if that runs. So it looks good. Let's see what that would look like. Whoops, that does not work. If we channel this, if we redirect this standard output to a file, then we can generate a web page that way. So now we have a web page in the file system, and we can open that up in a browser. And I'm not so let's go ahead and do that. I'll call it test.html. And let's paste in the those codes. I won't get them all, just get some. And we can double click on that file, and there, this is our web page. It's a numbered list that displays random color strings that we generated with our code. You can view the source. It shows the HTML that we generated. Okay, that's how the browser interprets the HTML document that our code generated. All right. Oops, not this one. So we have that get color string here. What's that? Oh, sorry. Thanks. Yeah, that's right. Exactly.
So we don't do anything to that code, we just convert it to HTML.
That's right. That's right. You just use the program to generate the HTML file. Is that clear?
One more time.
I'll show it to you again. I'm just going to clean this up a little bit. It's easier to do this in an IDE, by the way. This is kind of the slow way of doing it. But this is how you're doing it. All right. Some irregularity in the spacing here. I still want to fix that, and I want to emphasize that you should keep your code indented and spaced consistently. And that's what I'm doing now. I'm just applying a consistent spacing policy to the code. There we go. So once we create the code, you build it and run it. But when that's those cout commands, well, cout's not a command. Cout is actually an object, and we're going to talk about objects today. Cout is an object that represents standard output stream. So the program is writing into this thing called a standard output stream. But that stream is a flexible thing. It can be directed to different places. By default, it's directed to the console, so that when we write to the standard output stream, we see the characters displayed on the console. But by using this redirection operator here inside this terminal window, we're telling the operating system to redirect to assign the standard output stream to a file, and that when we write into that file, that the characters are just stored in that file. So you won't see, it doesn't display anything on the console anymore because the output has been sent into the file. You can look into the file, there it is. Is that okay? It works the same way on Windows and Macintosh. All right, so now let's do Lab 6. Did I create a folder for that? No. Lab 6, Exercise 1. I'll copy over the main.cpp file from the program that we just worked on. And let's go back to the problem statement. So we want to reorganize our solution to Lab 5, Exercise 1, so that the code is object-oriented and relies on a class called WebPage. Implement WebPage so that it adheres to the following UML class diagram. So this UML class diagram, this is a standard way of illustrating or representing a class and how a class functions. So there's 3 sections. There's this section here, which is simply the name of the class. There's the second section, which is empty right now. Later we'll put things in there, but not for this problem. And this second section holds the names of member variables that are members of the class. And the third section is the names and some of the details about the member functions. So a class contains 2 things. It contains variables and functions. They're called member variables and member functions. Like, you know, when we wrote a loop and we had the opening brace and the closing brace, and then inside those braces we could declare variables and do things. So that's the section, that area inside the opening and closing braces is a scope. When you declare a variable in there, it's meaningful just within that scope. Code that's outside those braces can't access those locally scoped variables. And it's the same concept here. These are functions that are members of the class, and in the future we'll have member variables as well. It's as if those variables and functions were declared inside the scope of that class. They're just, that's where they belong, that's where they're contained, just like we would put things inside of the opening and closing braces inside of a loop. But this plus symbol here means that this function is visible to outside code. So if there's code outside of the class, that code can actually call that function. But this minus sign here means that the function is not visible to code that is outside of the class. Code that's outside of the class cannot see, cannot invoke get random hex digit. That's a function that can only be called by code that's inside of this web page class. That's the meaning of the plus and minus signs here in the UML class diagram. So what I want you to do with your work is to embed these UML class diagrams inside your source code files. And let's see, I think I asked you to put it in the header file. Let me check that. Place the class declaration in a file called webpage.h. And actually, that's a good place to put the UML class diagram as well. So this is a multi-line comment. You have a slash and an asterisk, and then you have the multiple lines that you want to put in there. And then you close the comment here. So here is the here's the UML class diagram embedded into this file as a comment. Maybe I'll leave this out for now. So this file here is called webpage.h. It's the header file. It contains what we call the interface to the class declaration. The class name is webpage. And then inside this declaration, we have the word class followed by the class name, an opening brace and a closing brace, and a semicolon. Don't forget the semicolon. And what we do here is we have two sections. We have a public section and a private section. And that's how those are listed. And you can see that we have these functions here, web page and print, which are in the public section, and these other two functions are in the private section. That's what the minus signs mean for those. So let's go ahead and type that in there. Web page and print. And then in the private section, we have two functions. Get random hex digit and get random color. So this is a declaration of the class. It doesn't have any implementation. It doesn't do anything. It just shows what are the member variables, what are the member functions. Well, there are no member variables here. They're just member functions. This is a special function here called the constructor. And we know it's a constructor because the function name is exactly the same as the class name. So that's called a constructor. Most computer languages that have objects follow that pattern, but not all of them do. So we have a constructor here, and the constructor in this case takes no arguments. It's like a function that has the same name of the class and takes no arguments. Also, the constructor is not declared as returning any value. Now, print is not a constructor. It's a regular function. And all functions must be declared as returning a value, all functions except constructors. I don't know whether you want to actually call a constructor a function or not, but functions must be declared as returning a value. And in this case, print returns a void. Yes?
Can you make the text larger because I can?
Yeah, I can make it larger. It's in here somewhere. What's that? Oh, here. Oh, there it is, yeah. Let me try this one. How's that? Ah, everybody can relax, huh? All right, so this here, I think what I'm going to do here, I'm going to use screen and jump around a little bit. Oh, it's not installed. Can't believe it. All right. So we have, if you look at what's in the directory already here, We have a main function and a webpage.h. I'm sorry, a main.cpp file, webpage.h, and we also need webpage.cpp. So, although there are other ways of defining the classes, that the standard way is to have, for each class, you have two files. One is the header file, ends with a .h. The other one is the implementation file, it ends with a .cpp. There are other schemes, but this is the common one. And what we do in this file, web.cpp, is that we implement the functions that are declared in the class. But the first thing we do is we need to include the contents of the header file. So what that's called a compilation or a pre-processing directive. The preprocessor directive. This says, go get that file, take what's in there, and just paste it right here. So you could, in fact, omit this include statement and just paste the contents of that other file in here. It would have the same effect.
But that's useful like if you want to have multiple files accessing the same file, that way you don't paste it every multiple times, you can just include it.
Exactly, exactly. In fact, that will be our case, because main is going to use that file as well. And so inside main, we also need to have the declaration of the web page class, and so we will include that in main as well. So rather than duplicating the code into two separate files, we keep the code in its own file and just include it with this include directive. So the first thing we're going to do is define the constructor, which actually it does nothing. The second thing we'll do is define the print function. The print function returns void. That means it returns nothing. And it looks like this. And let's do this for the print function. Let's just print hi for now. It's not what we're going to do in the long run, but just to get things, just to test things. We'll just do something simple. This is called a stub. So we're implementing the print function as a stub. Now look at the form here. The function name appears here. Normally the print function would look like this. Let me show you. Normally, what we've seen so far, the print function would look like this. That's called a global function. It's not a member of any class. To make it the member of the web page class, to tell the compiler that we are implementing a function that is inside of the web page class, we use the syntax here. We precede the function name with the name of the class followed by 2 colons. Now the compiler says, oh, I see, you are implementing a function that's in that class. You're not just implementing a globally scoped function. You're implementing a function that's scoped to that class. Now the return type of the function is out here on the outside. It takes a little while to get used to this format, right? So here, this web page : that's a qualifier. It qualifies the identifier print. So we don't put that in front of void. We're not qualifying the identifier void. Void is a reserved name in the language that means something that's important that the compiler needs to know about. So we use we need to qualify the function name. All right. Same with the constructor. So the constructor is also, here we're telling the compiler web page is this is the beginning of our implementation of the constructor for the web page class. Now let's put the other ones in there. So here's the declarations from the other member variables. I'm sorry, not declarations. The implementations of the other member functions, rather. Once again, the way it looks now, these are just globally scoped functions. But we want to put them inside. We want to tell the compiler that these are functions, these are implementations of functions that are declared as being members of the web page class. Now, these return strings. So these, as I wrote it just now, these are not good enough as stubs. They won't compile because they don't return strings. So we need to return a string. Let's return X. Now these are stubs. They return something. In fact, maybe a better stub. I'm not sure what the better stub is. We can just return an empty string. It's even more minimal. All right. Now there has to be some code that's going to use the class. And we're going to put that code inside the main function. I think I'll get rid of this for now. So how are we going to use this function? I mean this class. We create an instance of the class. And that's the statement right there that does that. This statement here results in code, that the machine code that the compiler generates, that creates an instance of the web page class. And that we can refer to that instance from this point forward by using the identifier web page. And notice the difference. This is a lowercase m. This is an uppercase. I mean, sorry, a lowercase w. This is an uppercase w. Yeah, question.
I was actually about to ask about that. Why is it?
By convention, this thing is called Camel Case, and there's two words in this class name: web page. And so what we do is we capitalize the words inside the name. And this is a reference to the class web page. It's also the data type. It looks like this, similar to this form here, integer x. See, x is the name of the variable, and that variable has type int. So there's the data type followed by the variable name. Int will be an instance of int. X is an instance of int. Similarly, lowercase web page is an instance of uppercase web page. The data type is web page, and the variable is web page, but they're spelled differently. It's case sensitive, right? So those two identifiers are considered two separate names by the compiler. now that we have the web page object, print returns a string, right? No, print does not return a string. So that's it right there. Create an instance of the web page and print the web page. Let's see, this isn't going to compile, and why not? Let's see, take this out. We don't need any of these declarations. Does anybody know why this isn't going to compile? Well, we're using string here, and we need to include the header file for string. Also, we'll need using namespace std. Let's compile everything. How do we compile this? If we just compile it like this, it reports a problem, undefined reference to web page, right? That's because we need to include all the files, all the implementation files on the command line when we run the compiler. Well, cout was not declared in this scope. Does anyone know how to fix that? See, we're using cout here, but we need to include the header file that has a declaration of this. And also we need that using namespace as well. All right, that works. So what's going to happen when we run this? Just prints hi, right? Because all we have for when we call print, we just print hi. Let's see if it works. There, it works. All right. All right, let's actually, we don't need to modify webpage.h anymore. That's kind of set. We need to go ahead, we need to go forward and implement these functions. Get random hex digit. Random hex digit will look something like, say, 0. Get random color. Well, that will be something like 12 AA 9D DE. So that's what that'll look like. And this print function will look something like this. We print the HTML codes. Now we have code for this already. We've done this already, so we can copy and paste. But I want to kind of go a step at a time here. So we have the other stuff in here, the other HTML code that needs to be printed. And in the middle, we have that loop that runs 100 times to generate the 100 list items. So this is the code. List item I. And actually this this is going to be a color. So in fact, what we can do here is get a random color. We'll do it like this. So we use our getRandomColor function to get the random color, and then that's what we print in the in our list. Something like that. Maybe I'll get rid of this, too complicated. I just clean that up, just to simplify it. So we're going to print some list item. It's going to have the string color appear in that twice. And we've done this already, but I'm just showing you the body, kind of the overall structure of what's going on. So when print is invoked, we print this starting HTML code, then we enter a loop that runs 100 times. And each iteration of the loop, we get a new random color string. And we use that to build that list item. And then when we're done that loop, we print the ending HTML code, and we're done. Unknown escape sequence. \h. And look, it's only a warning. That means it still runs. Let's see what it looks like if we run it. It didn't really make a difference there. So it was a warning. Well, let's fix the warning. Where is the \h? I don't see that. Oh, here. Sorry, this is not the right slash. That should be a /. Alright, so now it runs the same way. So here's our list again, once again. But it's a little too long to work with, so let's shorten it up temporarily. There it is. Oh, sorry, here. So we have the opening HTML code, then we have the list items here that have the random color value. But let's drop in the real code here. And that comes from lab 051. this gets the random color string here. And this code in here is what gets the random color value. Well, let's see, that's 16, that's 18 lines. We'll just drop that right in there. So when we want a random hex digit, what we'll do is generate a random value, divide by 16, take the remainder, and then return a string with a 0 in it if the random value is 0, and so on. That's it right there. So this function simply returns a single digit. Oh, look at that. I was fixing my indents, and look what happened. I found the bug. And, you know, I'm really hammering away at that you really have to be meticulous about writing clean code, because it helps solve the problems more quickly, believe it or not. That's an illustration right there. Okay. So now we're generating a random hex digit here. And let's go ahead and drop this code in there. Here we need to generate 6 random hex digits and use them to create a string. So let's declare the string here. This is its initial value is empty anyway, but let's go ahead and be explicit about that. And so we're going to execute the loop 6 times, and let's just append the 6 random digits. So we call the function get random hex digit. Random hex digit. And the value that random hex digit returns, let's append it onto the color string. So we use plus equals for that. And now the print function up here, let's keep this alone. Let's just see, let's stop at an intermediate point and test our solution at this point. We're not finished yet. Rand was not declared in this scope. So we need the include file for that. I think it's C standard lib. I'm going to guess at that. That works. Segmentation fault. Oh my gosh. The runtime error is not a compile time error. It compiled all right, but it just didn't run correctly. Segmentation fault means the code is trying to access memory that wasn't allocated to the process. So it's doing something illegal according to the rules of the operating system. When the program, an instance of the program was created, that's called a process, and it was assigned a block of memory that it could use. It could read and write into a block of memory. But the program, the running process, is trying to access memory outside of that block. All right, let's look through this carefully. Let's see, how are we going to do that? Let's try to rather than reading the code, let's figure out how we can isolate that problem. I'm going to comment out this line right here. So we never call get random hex digit. Let's see if it still runs. No, it doesn't. So we know that the problem is not in get random hex digit because this code here never runs. Where can the problem be? Oh, we're not returning a value when the compiler doesn't warn about that. We need to return string here, return color rather. See, this function is declared as returning string, and we don't return anything. I'm surprised that the compiler didn't give us a warning on that. I think what it did was it generated a return of, what did it do? I think it returned a 0, and that's the by returning a 0, it's like a 0, a null pointer, and that's what did the segmentation fault. All right, let's see if that fixes it. What's that? Just random. Okay, that did it. That was the problem. And let's bring this one back in there. All right, looks good. Now we've got random strings. So we're almost done. We just need the, and let's go ahead and get the, let's get the code that we've already written. We'll put it here. There it is. We seed the random number generator, but we really only need to do this once in the lifetime of the program. So we could move that up here. Although we only call print once as well. It doesn't matter that much, but we could do that there. And by the way, we need to include that C time header. which has a declaration for this time function. So we're seeding the random number generator with the current number of seconds since the January 1 of 1970. And let's get rid of this. This is our old code. So we declare a variable color here. And then we have our loop here that goes 100 times. We want to get the random color. What did we call it? Get random hex? Can't remember now. Get random color. No, just get random color. And then we use that inside this this expression. And then we output the rest of it. So there it is. Did I do that right? I better test that. This is, let's make that 5. Compile and run. That looks good. So we can store that in a file. Colors.html. Okay, that's that one. That took a long time. It's already 1 o'clock. That is the solution exercise 1. Let's take a look at what I'm asking in exercise 2. Re-implement the web page class of the previous exercise so that the random color value is generated in the web page constructor, so that it is not recomputed on each invocation of the print function. But that doesn't make any sense. I'm going to need to rewrite this one. Modify the web page constructor so that it takes an integer argument that represents the number of random color entries to generate for the page. I think what I wanted to say here was the random web page is generated in the web page constructor. The random, or the web page, not the random web page. So that the HTML, how about this? So that the HTML code is generated in the web page constructor. There we go. So when we construct an instance of the web page class, let's generate the HTML string. And then when we call print, we just print the string. Add a UML class diagram to show this. So actually the hard part here is to figure out what the UML class diagram looks like. So let's do that now. In fact, actually it's very easy to do the whole problem, and I think we can finish it. Let me let's do problem 2. Oh.
You listed 0.
Yeah, I didn't name it the way I normally do. And let's go ahead and fix this. So now the web page is going to take an integer value. I call it the, say, number of colors. We still have a print function, and these are still very useful. But now we have a member variable. And it's going to be private. And let's call it the HTML. It will be of type string. So now we see an example of a member variable. So what happens is when we create an instance of web page, we're going to pass in a number and say that's how many random colors I want in this web page. And inside the constructor, it will call getRandomColor this many times and construct this string internally. And then when print is called, we just simply print the string. This is going to be pretty easy to do, so let's just do that. So the constructor takes an integer called number of colors, and this name is arbitrary here. And we need to add a private member variable called HTML. And here, this print function has to be reorganized. We're going to put that in here. Now instead of cout, we'll just append onto this HTML string. And for print, we'll simply just see out the HTML string. That's it. One little change more. We need to pass in this value here. This is how you let's do 7 numbers, 7 random colors. So that's how you invoke the constructor and passing in an argument. Actually, there's one more issue that we need to do there. We're not using what the constructor passes in. So here, oh, I see. This has to, the constructor has to be has to take an integer. Number of colors, and then this loop here is number of colors. And that's pretty much it. Oh. Oh my gosh. What did I do wrong? I think I forgot a header file. This is okay. This is okay.
You don't have
Yeah?
variable called number of colors to increment. Where is that?
I don't have the what?
It goes through that loop and it increments the number of colors in time. Where's that?
This is where it's incrementing I. Oh, it's here. That's the problem. We can't use that output operator. Yeah, I'm trying to go too fast. All right, so that output operator is not defined for the string class. We'd have to we can use what's called a string stream, and but I'm not going to get into that. There we go. There it is. 7. So that's how to do exercise 2. That wasn't too bad. The key is to, understand what it is I was asking there. We need a member variable to store the string, which is, it's private. That's the minus sign. And the constructor now takes an argument, which is an int. And the rest of so normally when you solve these kind of problems, you got to figure out what does the class look like to the outside? What does main do? What does main call? And then go from there. Okay, that's it.